Hey there guys, welcome to the Code Lab channel and welcome to part 1 of this 2-part tutorial where we're going to be learning everything you need to know about asynchronous programming. Before we get started guys, if you like the content, don't forget to like and subscribe and make sure you hit the notification bell so you never miss an update. So as mentioned in the intro guys, this tutorial is a 2-part tutorial. In this first video we're going to be learning everything there is to know about asynchronous programming. So we're going to take a look at what synchronous programming is, asynchronous programming, taking a look at callbacks, and then a thing called callback hell, JavaScript promises, and then an even better way to write promises with async await. And then we'll use everything we learned in part 1 by creating some really cool projects in part 2 using APIs. So before we get started on that, just a few prerequisites. You're going to need a basic understanding of HTML, a basic understanding of CSS, and also a basic understanding of JavaScript. So without wasting any more time, let's get into the video. So before we actually dive into what asynchronous programming is, we'll first take a look at what synchronous programming is. Now synchronous programming, as you can probably tell from this slide here, is that it just follows a strict set of sequences. So when the code runs in synchronous programming, it will follow each step in order. So it will do task 1, and then it will do task 2, and then it will do task 3. It will never do task 3 first or task 2 first. It will always follow in a synchronous manner, so it will be sequential. So let's go into VS Code now and just take a look at some synchronous programming to really drill in this concept. So we're inside VS Code here, and as you can see when we take a look at the code here, we've got a list of things to do to make chocolate brownies. Now I'm logging all these tasks to the console, so when I uncomment them, we'll take a look at the console here, and we'll see how this is working synchronously. So we'll go ahead and do that now. I'll uncomment these. And as you can see from the console, it's doing it sequentially. So it's logging the first one, then logging the second, third, fourth, fifth, sixth, and then finally seventh. And this is what I mean by synchronous programming. The code will execute the tasks in the order that you see them, and then it will just wait for each task to be completed before moving on to the next one. Now the problem with this kind of programming or synchronous programming is that it can be problematic in certain situations. And that's particularly evident when you're dealing with tasks that take a significant amount of time to complete. So let's say for example that a synchronous program performs a task that requires waiting for a response from a remote server or an API. The program will actually be stuck waiting for the response and won't be able to do anything else until the response is returned. And this can sometimes be known as blocking, and it can lead to a lot of applications appearing as unresponsive or frozen, which is what we want to avoid. And the way we can avoid that is with asynchronous programming. Asynchronous programming is going to be the process that allows the application to run a second set of instructions while also focusing on its primary or basic process. And several of the benefits of asynchronous programming is things like improved application performance, wide application to different code languages, and it's just better for overall user experience. A few use cases of asynchronous programming includes reduced inefficiencies from an application, as well as efficient data collection, which we will focus on in part 2 of this tutorial. And to really drill this concept home, in a real world example, you can sort of think of asynchronous programming as essentially application multitasking, where we're doing multiple things at the same time. So as I just mentioned, asynchronous programming is going to allow us to write a program and for that program to continue working on other tasks while we're waiting for external events, such as a network request to occur. So let's go ahead and look at a basic example of asynchronous programming using the set timeout method. So we're going to be using the same console logs as we did for the chocolate brownies. We're going to be building this basic app, but of course with a set timeout function. But before we do that, let's just number these so we know which order they're in. And I'll speed this up just to save some time. You can see now I've put these all in a set timeout function, but if you take a look at the console now, you can see they're not firing off sequentially anymore. See, it's actually firing off number 8 first, and then number 1, and then 3, and then 7, and 2, 4, 6. So it's not running sequentially, and it's not running in the order that we want it to. This list now doesn't really make sense, and the reason why this is happening is obviously is because in this example, the set timeout function method execute a function after a specific time. So all of these numbers that you see here is represented in milliseconds. So 1000 milliseconds is equal to 1 second. So first one is 1 second, second one's 2 seconds, second and a half, 3 seconds, 4 seconds, 3 seconds and a half, 1.8 seconds, and then half a second. So the function passed to the set timeout functions will be executed asynchronously, which means that the program will continue to execute the next line of code without waiting for the other set timeout to complete. So this is just a basic example of what asynchronous programming is using the set timeout function. Now say that we want to fire these off in the correct order. What we can do is use these set timeouts, put them inside functions, and then use callbacks to fire them off, which I'll explain in just a moment what callbacks are, but first let's just put these set timeouts into functions. So we'll just go inside the first one, and we'll say function task 1, and then set task 1 inside of there. And then we'll do the same for the second one. And I'll just speed this up because obviously you guys get the gist of what we're trying to do. So we've got our functions here, and the way that we're going to fire this off in the order that we want it to, we're going to insert a callback inside each of the tasks as an argument. So essentially what a callback is just a function that's passed in as an argument to another function that will then execute the callback based on the result. So essentially they're just basically functions that execute only after a result is produced, and callbacks have been quite an important part of asynchronous programming. So we've got our functions here, and the way that we're going to fire this off in the order that we want it to, we're going to insert a callback inside each of the tasks as an argument. So essentially what a callback is just a function that's passed in as an argument to another function that will then execute the callback based on the result. Essentially they're just basically functions that execute only after a result is produced, and callbacks have been quite an important part of asynchronous programming. So what we'll do is, inside of task 1, we'll give it an argument of callback, and then we need this to set off inside of here, so we'll say callback, and then we'll do the same for task 2. And again, I'll speed this up. So now we've included our callback as a parameter, and then every time a section is complete, we then execute the callback to the next function, and this is just going to give us the ability to now fire off this list in the correct order. So the way we'll do that is we'll go at the bottom here, we'll grab task 1, and then because task 1 takes a parameter, it's going to take in that callback, but we're just going to use an arrow function here. So when task 1 is complete, we'll then want to grab task 2. Task 2 also takes in a callback. Task 2, and then after task 2 is completed, we want task 3, which also takes in a callback, and then task 4, again taking a callback, task 5, task 6, task 7, and then finally task 8. So if you take a look at the console now, you can see it's starting to load in the correct order. So it's going to load task 1. Once that's done, task 2, then task 3, task 4, task 5, task 6, task 7, and task 8. And you can see it was taking the amount of time that we've actually included in this callback in the set timeout function. So you can see task 5 there took the longest because it was 4 seconds long, or 4,000 milliseconds. Now you may have noticed that after all this nesting that it's starting to form like a pyramid format, and this is what we would call callback hell, which is where you run into the trouble of nesting loads of callbacks inside of other callbacks. And if these functions weren't written so methodically, it can actually become quite unmanageable and really difficult to read. So that's what's called callback hell. Let's take a look at a more practical example of callback hell just so we can really drill it in. So say in this example we just want to write a simple message to display in the console, but we want to do it asynchronously using callbacks. So what we'll do is we'll just create a function here, which we'll call, let's just call it show message. And this is going to be a arrow function, and then this arrow function is going to take a callback. So we'll just put in here callback, just like we did in the previous example. And then what we want to do is just console.log that callback. So we've got a message here that we want to display, and then what we want is a function to first display the first part of the message. So we'll say const, let's say first message. This is also going to be a callback, and we'll give it an argument of callback. And we'll say set timeout. It's going to equal an arrow function, which is also a callback. So inside of the set timeout function, we want to trigger this show message, and which is going to display that first message. So we'll say show message. We want that to display hello, and then after that we want to fire off our callback, and we want this to be, let's say, 2000 milliseconds long. It's 2 seconds long. And then for the second part of the message, we want to create another function. So we'll say const second message. This is also going to be an arrow function, and then we want to grab the show message function again, and we want to write our second word, which is going to be world. And then to fire this off, let's call that function. So we'll call first message, and inside of first message we want to give it a callback, which is going to be that second message. And if we wait 2 seconds, you see it prints out hello world. Now it's quite a simple explanation of just using 2 words, but you can see already that writing it this way using callbacks can quickly become unreadable and really hard to work with. If we start adding more functions inside of this, you can see it's going to become unmanageable. So let's say we want to add more words, like a third message, using the show message function here. We're going to have to insert it in our second message, and then if we want to add another one, we'll have to insert that inside the next function. And again, that's just going to create a massive headache for you and then lead to callback hell. So to combat this, we now use a thing called promises. So what exactly is a promise? A promise is essentially just an assurance or a guarantee that something's going to happen in the future. So in real world terms, a person can promise another person a specific outcome or a result. Programming terms, a promise is an object that holds the future value of an async operation. So for example, requesting some data from a server, the promises us to get that data, which we can then use in the future. Now, before we get into all the technical stuff, let's actually just break down and understand the terminology of a promise in a programming sense. Now, a promise in JavaScript, just like a promise in the real world, has 3 states. So it can either be pending, it can either be fulfilled, or it can be rejected. So when a promise is pending, it essentially means that the result is not ready, i.e. it's actually waiting for something to finish. So for example, an async operation will be stuck on pending if it's not ready. Now, depending if the promise is fulfilled or rejected, then if a promise is fulfilled, it means that the promise has been resolved and the result is available. Whereas if the promise is rejected, it essentially means in a programming term that an error has occurred, which you would need to address. So now that we know what a promise is, and we also know the promise terminology, let's go back into VS Code and look at all sides of promises. Now, before we create a promise, I just want to highlight that most of the time you'll actually be consuming promises rather than creating them. But again, it's still really important to know how to create promises, just so you can really drill the concept and how it works in your head. So the syntax of a promise looks something like this. So first, let's just create a const, and we'll just call this promise. And this is just going to equal a promise constructor. So we need the new keyword, and then we'll use the promise. Now inside of the promise constructor, this takes a single argument, which is essentially a callback. This takes 2 further callbacks, the resolve and the reject. So we'll put in here resolve and reject. And this is going to be an arrow function, and then we'll just close this off. And that's the simple syntax we use to create a promise. And then inside the curly braces, we of course just have code that we want to execute. Now in terms of the promise, this arrow function inside of here that we just created that has the resolve and the reject callback is immediately executed when this promise is created. And then once the promise is created, it's either resolved by calling the resolve callback, or it's rejected by calling the reject callback. Let's look at a really simple example. So we'll just create variable and we'll call it, let's say const. Let's create a boolean. This can actually accept anything, so it can accept booleans, numbers, strings, arrays, or even objects, but we'll just keep it simple and use a boolean. So we'll say, let's call this all went well, so this equals to true. So we'll have our if statement in there. So if all went well is equal to true, then we want to grab the resolve callback, and then we'll just log in here, all things went well. Else, we then have the reject, which we can say, oops, something went wrong. Now let's log this into the console and see what we get. A promise. Take a look at the console now. You can see now the promise is in the fulfilled state, and then let's just showcase what would happen if it fails this. So let's just set all went well to false. You can see now the promise is in the rejected state. It should probably be oops. So you can see from that example the two different states that are presented when we're creating promises. Now remember with promises that there's also another state which we saw on a slide, which is the pending state. It's essentially just when a promise is pending, if the result isn't ready, the state of the promise is going to be set to pending. So let's take a look at another example to fully understand the three states of promises. So we'll just take this off and we'll go inside here, and we're just going to create a variable which is going to be a random number. Generate a random number, we're just going to need the math.floor method, and then the math object again, grab the random, and then we want this to be between 0 and 9, so we'll say times 10. That's how we can generate a random number between 0 and 9, and then we'll use the set timeout function. Which is going to accept that resolve and reject. So we're going to say if random number is less than 4, we want to grab the resolve, and we want it to display, let's say, well done, you guessed right. Else, we'll grab the reject and we'll say oops, you guessed wrong, unlucky. And then we'll make this so it's 2 seconds long. Now if I log this to the console, so I log in the promise, you can see that initially it's set to pending, and then after 2 seconds it then hits the reject, so it's saying oops, you guessed wrong, unlucky. And that's how you can see when a promise changes its different states. When the promise is first created, it will be in the pending state, and then after 2 seconds from the set timeout function, the promise is then either going to be resolved or rejected randomly. And you can see in this case it's been rejected. And then again, that's just a simple way we can demonstrate how a promise works. So initially when you set a promise, it's set to pending, or it's in a pending state, and then depending on the outcome, it will either resolve or reject. So those are the 3 different states of a promise. So now we've grasped the 3 different states of a promise. We can't actually do anything with this data at the moment, despite it being fulfilled or rejected. We actually need to consume the promise to then access that data. So using this example, let's understand how to actually consume an already created promise. So if I just get rid of this console log here, the way we actually consume a promise is, well, there's actually a couple methods, but let's learn the older methods first, and then we can learn the newer ones in just a moment. So the older methods of consuming a promise was using methods such as then and catch. Now the syntax of then and catch just makes it a little bit more easier to read and consume a promise than it was previously before when we're using nested callbacks. So let's just dive into this example and you guys will be able to see. So again, we're using this example. If I grab the promise and then I apply a then method to this, the then method itself actually takes a callback when the promise is resolved. It takes one argument. Now the argument is actually this content here. So whatever's inside the resolve, this is what's going to be outputted. So let's just call this, value. So it makes a bit of sense. And then all we need to do here is just console.log this value. And if you take a look at the console now, you can see we're getting the content inside of the resolve and we're getting the actual content. We're not just getting a fulfilled promise, and it's quite important to distinguish this. Now, as well as a then, we've also got a catch. So in case of a reject, so under this then, we can grab the catch method. This also takes a callback. And again, this is just going to be the value that the reject outputs. So let's just say, let's call this error. And then let's do the same thing in console.log the error. And you can see now, instead of getting that red error like we did before, we're actually getting the output from the reject. So we're actually getting the value from the reject callback of the promise. So you can see how this is actually a lot cleaner than using the conventional way of callbacks or nested callbacks. So let's just quickly go over all of these steps. So how we got to this value. So we create the promise, and when the promise is initially created, it's going to be in a pending state, meaning that it's just waiting for a result. Now promise accepts two parameters, the resolve and the reject. And then when we set a condition, we either want it to resolve or we want it to reject. So depending on whether the random number is less than or greater than 4, it's going to resolve or reject. And those are the three states of a promise down to its bare bones, but we're not actually able to access the data yet, whether it's resolved or rejected, because we need to, as I mentioned, in majority of cases, is actually consume that promise. And the way we consume that promise in this example is just using the .then or the .catch, which themselves accept the callback, and the values inserted inside of that parameter is going to be the values that are inside the resolve or the reject. And that's how we get into our value here. And again, you can see how much cleaner it is to actually write this promise and then consume it. Now, another good thing about .then and .catch in relation to promises is that we can actually chain promises onto other promises. So let's just create a few more promises from this. So what we'll do is we'll just have a resolve in here. And this is just going to say, well done, promise 1 is resolved. And then let's just duplicate this a couple more times. Say promise 2, promise 3, and then we'll say well done, promise 2 is resolved, and then promise 3. Let's actually reject promise 3 so it fails. Rejected. Unlucky. So then again, what we can do from here is actually chain onto these, so we can fire off these promises. So we'll leave the .catch for now, and we'll say what we can actually do, because this is chaining on, we can make this look a little bit neater. So we can say .then inside of this value, we'll console log that value, and then we'll just return promise 2. And then after that .then, we'll create another .then, or we'll chain another .then, and then we can also log that value. Give this, paste that in here, and then we'll fire off a third promise. But the third promise, we want this to actually fail. So let's uncomment the catch, put that in there, and obviously change that up there. So we can see how now that's actually firing off the 3 different promises. We have our first promise, which we have a then method attached to it, and that value is going to be the value that we have in the resolve. So we log that to the console, and then we return promise 2 after that, which fires off the second promise using the .then. Then we access that value of that resolve, and then we return promise 3. Promise 3 is rejected. We then use the catch method to log that value, so that value of this reject, to the console, and you can see how now that's firing off synchronously while using asynchronous programming. And again, you can see how much neater it is writing the .then and .catch methods when working with promises or when consuming promises, compared to how asynchronous programming before used to work when we were using callback functions and then eventually running into callback hell. Now, a common mistake from beginners is that they might make the mistake of nesting promises inside of other promises, which is essentially similar to callback hell. So if we take a look at example, console.log, just the dot then for now, then inside of here what we'll do is actually grab our second promise. So we'll grab promise2, and we'll apply a then method on here to then display that data, and then we'll just console.log the data, and then nest the third promise inside of here. So let's promise3, and we'll just put in here data as well, and we'll just put in here data, console.log data, and then on this we can just attach the catch, and the console.log the error. Then you might even have a .catch after this, so you can put another console log, will just log us to the console. Now, although this actually works perfectly fine, as you can see in the console, it's considered to be quite a poor style and just really makes our code pretty difficult to read. And if we have a sequences of promises to resolve, it's actually better just to chain the promises one after the other, just like we had before, instead of nesting them like here, because then this is actually quite difficult to read. We've got several catch methods, and it just essentially defeats the point of chaining our promises, and we're essentially just going back to callback hell. So it's much better to just keep it simplified if we revert it back to how it was, where we're just chaining the promises one after the other. So that's a common mistake you should definitely avoid. Before we move on to some of the other ways we can consume promises, I just want to touch on a particular method that can sometimes be useful. Now, this method is particularly useful when you've got a bunch of promises that you want to fire off or that you want to check, and that if one of them gets rejected, then it all fails. So you're essentially just checking if the promises are fulfilled. One of them from that bunch of promises fails, then the whole thing fails. So that method is actually the .all method. So let's just take a look at an example of what that looks like. So what we'll do is just create two promises. So promise 1, set that equal to new promise, and of course have our resolve and the reject, and then inside of here we'll just have a set timeout function, which is just going to resolve. So we'll say promise 1 resolved, and we'll just make this 2 seconds long. So that's one promise, and then let's just duplicate this, change it to promise 2, and let's just make this say 1.5 seconds long. So what we can do now is group these promises together to fire off these resolves at the same time, or if they're fulfilled. So the way we do that is we'll just grab the promise .all method, and then we'll insert our two promises in here, so in an array format. So we'll insert promise 1, promise 2, and then to consume this we just have the .then method. This is going to accept a value, we'll just call it data, and then what we want is just to console.log that data. So for the first array, it's index, so it's going to be 0, and then for the second one it's going to be indexed at 1, and then let's just apply a catch method to this because we'll need it in just a moment. So we'll put the error console.log error. Oh. It's console.log. So as you can see now, after the set timeout function is fired off, you can see we get both of our promises in one line because we fired it off here in the console. So that's how we can consume several promises at the same time using the Promise.All. Now this is especially handy for the second situation where, just in case you have, say you've got 5 promises and you want to check that all of them are fulfilled before shooting them off to the console. If one of them fails, then the whole thing fails. So what we'll do is we'll just set a reject here. We'll say promise to rejected. And you can see now, instead of firing off both of the promises, it's only firing off the rejected one, because now essentially the whole thing has failed. And that's what we can do with the Promise.All method. So again, this method is particularly useful when you've got more than one promise and you just want to know when all of the promises have resolved. So for example, if you're requesting data from a different API and you actually want to do something with the data, but only when all of the requests are successful. If one of them failed, then you want the whole thing to fail. So that's just a method that you might find useful in the future when working with promises. So now we've seen how promises work under the hood, let's take a look at the final and current stage of how we can work with promises, or how we can work and consume promises, and that's using the async await. Now async await is essentially just syntactic sugar built on top of promises to make it easier to work with asynchronous code. So essentially an async function will return a promise, and then you can use the await keyword inside that function to await for the promise to resolve. And the idea being essentially that the code looks more synchronous and easier to read. So let's use that example like we did before where we created chocolate brownies. So we'll create 4 functions that are going to return promises, and then we're going to use the async await to consume those promises. So we'll create our first function here. We'll say const, say preheat oven, and then we're going to use an arrow function, and then what we'll do is just return a promise. Then we'll have our resolve and reject. And then inside of this, we'll just have a set timeout function, which is just going to have a variable inside of it, which we're just going to set to preheat oven is equal to true. And then we'll just have a simple if statement. So if preheat oven is true, then just resolve. And then we'll just have some text in here saying preheat oven to, let's say, 180 degrees. And then we can also have an else. So we'll say failed. Oh, sorry. We need to actually put it inside the reject. We'll just say failed task. And then we'll just make this, we'll say 1 second long. So we've got our first function that we're going to use, or our first instruction. We'll just duplicate this a couple more times so that we can use some more functions. So for the second one, let's just close these quickly. The second one let's call this one, this is going to be add sugar and choco chips. Open this up and just change a few things around. So we'll just say we'll say choco, add choco, if that's equal to true in here. We'll say place butter and chocolate chips, stir until melted and smooth. So that's going to be for that function. Then we'll have another function and we'll call this one, this instruction is going to be add the flour, cocoa and salt. We'll say in here add salt, flour, add salt, flour, and then for the resolve, just say add flour, cocoa and salt, and stir until smooth. And then finally we'll have one more, which is just going to be baking the mixture. And then we'll say bake mixture in there. If bake mixture is true, then we just want to say bake for 24 minutes for really gooey center. So that's all the functions, or essentially all the tasks that we're going to need. Again, these are all going to be returning promises. And now we all have our function promises to bake some brownies. We can then use the async await function to write these asynchronous promises in a synchronous manner. So like before, we might use the .then, we can actually just use the await keyword inside of an async function instead, making it look synchronous. So let's go ahead and create that function. So this function, let's call it const bake chocolate brownies. And then to make this an async function, we're going to need to use the async keyword before the brackets. And because we've now defined this as an async function, we can then use the await keyword inside of this async function. So let's do that first with our first task, which is to preheat the oven. So we'll just say const task 1 equals the await keyword, and we want this to return preheat oven. And then all we need to do is just console.log this. So we'll log task 1, and then we actually need to call this function. So we'll say bake chocolate brownies. And as you can see, it's telling us to preheat the oven to 180 degrees. You can see we're using the async keyword here to make this an async function. And then we're using the await keyword, which awaits a promise, being the preheat oven task. And then once it's completed that promise, well, either resolved or rejected, then it logs it to the console once we call this async function. And you can see it's logging it to the console. And again, the beauty with this now is that if we do it for the other ones, so const task 2 equals await. So we're going to await the add sugar and choco chips. We'll then log that to the console. Task 2. Just create a space between these, and then we'll do const task 3 equals await add flour and salt. We'll also log that to the console, and I'll just comment that out at the moment so it's not firing off. So we'll say task 3, and then finally we can do one more for the last one. So const task 4 equals await bake mixture, and then we'll just console.log this task 4, and then once that's done, we'll just console.log one last message saying enjoy your perfect brownies. Chocolate brownies, that's important. So now we'll uncomment this. And if we take a look at the console, we say preheat the oven, place butter and chocolate chips, add the flour and cocoa, bake for 24 minutes for really gooey center, enjoy your perfect chocolate brownies. So you can see now using the async await, we're writing asynchronous code in a synchronous manner. So first it waits for this promise, logs it to the console. Once that resolves, waits for the second promise to resolve, then the third, then the fourth, and then finally this last console.log, which I think you can agree makes using promises now look much neater, much more readable, and just easier to work with. And as I mentioned, it's important to note that these keywords are linked. So if I tried using the await inside of the, without defining this function as an async, you can see we're getting an error. Await is only valid inside async functions. So just make sure you make this an async function before you use the await keyword. Now, in regards to handling errors, what we can do is actually just use a try catch block to store all of these promises inside the try, and then if there's any errors, catch the errors. So we'll do try. We'll just grab all of these. Then underneath the try, we'll do a catch. Scroll this down, and then and then inside the catch, we'll log an error. So we'll say console.log the error if there is any errors. And what we'll do is actually just create an error so it fails one of these promises. So we'll just do it with the first one. So we'll make this false. And you can see now it's failed the task. And just to make it a bit more clearer, failed task 1. So you can see now it's hitting the reject, and then it's also just catching that error in the try catch. So again, you can see how easy it is to write async functions and use them with promises. Now that's going to be it for part 1. I hope you guys enjoyed the video, and I'll see you guys soon for part 2.